Hello and welcome to another tutorial on beginning C. This is part 19 and today we're going to be covering structs. Now structs have I've held off on structs because they're a little more advanced, and I decided to hold off until the end so you can learn all about the primitive types. But structs offer several things for you, and it's a way to group data together. So we're going to see in a minute how you can organize the structs, how to initialize them, how to copy them, how to pass them into functions, how to pass by reference, and how to access their attributes by reference when you have a pointer. And we can see that structs have also nested values. So a lot of this may not make sense to you because you haven't been introduced to structs. So let's get started. So I have a lot going on here, and don't pay attention to all of this just yet. So structs are a way to organize your data into groups, and sort of you can say they have their own namespace. So for example, we have the first definition of structs, and let me separate it so you won't see all the other stuff. So you have a struct and you define it with the keyword struct, and then you have you can have whatever attributes you name. Just think of them like your variables. So in this case, I decided to call one first name, and I decided to call another one last name, and they're arrays. And you notice that I have a constant plus 1, and I define my constant up here, so I can have a length of 30 plus 1. And the reason for the plus 1, and you see it commonly in just strings, whenever you use strings, is because you want to have 30 plus 1 more for the no character. So that's the reason that we add the plus 1. And so you have first name, last name, and age. Now when you define a struct in this manner, you can define the struct in this manner, and then you define a variable and you can assign the values. Now structs are similar to arrays in the sense that they occupy contiguous memory. So for example, in this case, you have Joe, which is the first name, Smith, which is the last name, and the age, which is 44. So all these are in contiguous memory, and if you wanted to, you could actually access them that way. But you know, when you access the attributes of a struct, you access them a certain way. So for example, if we take the struct and let's just create a function to display struct, and let's comment all of this code in the bottom for now. I'll just use it as my cheat sheet. And so let's say, for example, that I have a main, and main, the usual main void, and then I can start using person as my struct. So let's say I say, for example, I can initialize it the way it's initialized here, and I can display my struct. So let's create a function to display my struct. So let's just say void display person, and we can pass in the person, but this is interesting. So let's just not even pass it in. Let's just say printf, and we pass in. So we say person dot first name, %s for string, and we say person dot first name, and we continue to do this for also last name and age, and we just change our variables to say last name, and we have age. So we change this to last name, and we have age. And now we call this function and we say display person. And we had a problem. Oh, yeah. We have a problem because this should be a %d because it's an integer. So let's go ahead and fix that. And you can see that we can display that. Now we can do this, and we could even define more variables after our struct. So we can call P1 and P2, and when we display person, we can actually take and do that, and we can assign P1 equals person, and these are all variables. So now we have that, and we can do the same thing for person, and you can see that it copies the values. And of course we say P1 and then we can display that, and you can see that it copied over. And it's not the same values in memory. They have their own values. It creates it and it does it. But if you have a struct defined like this, then how do you define the type? How do you access? How do you create a new person? Well, the only way to do it would be to declare all your variables here. You could even declare an array, but that's not the best way. And this is what we call variable, or an anonymous type. So we don't want to do that. So another way of doing it is by defining it by tag. So let's take the person and define it by tag. So let's say, for example, that instead of doing this, that we take and define it by tag. Let me copy this here so we can move it down here. And we got to make sure we copy over the C. I have a sticky mouse. If you've noticed, I have a sticky mouse, and sometimes it doesn't want to get to the end and tag that. So there's another way of defining a struct, and that is to use by tag. So let's take a look at that. So let's say, for example, that instead of doing this, what we did here and define our variables there and being anonymous, we define it like this. So we can say paste, and now we have person by tag. So let's just change it to person. Now we can do the same thing and still define person by tag. We'll just call it person. And we'll use uppercase, it's a matter of convenience. And here we can actually declare our struct, and we can say struct person, and we'll name it person. And if we display it right now, and I got P1, because there's no such thing as P1. P1 equals person, because I haven't defined P1, so let's define P1. And you can see I get junk because I haven't initialized them. One way to do it, I can do it the same way. I can define my values here, and I can say Jane Doe and age 33. And I can do the same thing here and say Mike Jones, age 43. And now when I do it, you can see that I can do that. And one thing about structs is if they're the same type, you can assign them. Now, if you have two different types defined, so for example, I could have person defined and I could have another struct type defined. If they have the same variables, for example, let's say I had person and I had human or something, and let's say I define human here. I can initialize this the same way because they have the same variables. So let's say that I define, and let's change her name to Mary. Mary Smith, age 34, to be different, and we close off. So now we have human and person. Now if I wanted to display human, I can say the same way, access the same attributes, and I can say human. And I can say human here. And I can display human here. And you can see that. Now they have the same attributes, but they're not the same type. So if I couldn't, for example, do this. I couldn't say human equals person. This will not work. The compiler won't let me get away with it because they're two different types. So even though they have the same values, they don't have the same types. The other thing about this is that, for example, if we can still use first name. So in here we can say care first name, nameland +1 equals, and let's think of another name. Let's say Doris. Do that, and this is perfectly legal, and it won't give me a compiler error because this first name and this first name is two different things. So that's one thing about it. So let's go ahead and do this. And if I wanted to get input, let's say that I wanted to initialize my person. Let's get away from this. Okay, so we have a way to initialize, and this is another way of initializing by, this time it's by, this is not by tag, this is not anonymous, this is by tag, and we have the tag. So it's almost like you define the tag. The key thing is that you must also use the keyword struct in order to do it. So some people prefer not to do that, so we can define by type. So there's another way of doing this, and let's erase this. Let's not erase it just yet because we may actually need it to display person. So there's another way to do it, and that way is to just have the type. So we have to use the word type def struct, and we can say, okay, what is our type? So we can say person, and we could have said person type, but let's just do person. Let's get rid of human. Let's get rid of human here, and let's get rid of the stuff we don't need. So now, when I have this defined, I can say person. Let's get rid of all this. Oh no, let's not get rid of that one. Let's get rid of human. And now we can say that, for example, person, we have person in P1, and we can assign by value. We can say P1 equals person, and it copies all the values over. You can see it copies the values over, and it's actually copying the values over. It's not pointing to the same thing, it's actually copying the values over. So now that allows us to simply define person. We define our own types, and we can do that. So what if we wanted to assign the values without doing this? What if we wanted to assign values to person? Well, let's say, for example, we take person, and we want to assign our names after creation. So we can say something like this. We can say person dot age equals 19, and you can see that age jumped to 19, and the reason it's on both is because we copied the value over. Now we can assign also the value to the strings, right, to the character arrays, but it goes along with what we've been doing with strings. And so what we have to do is we have to use string copy, and we have to say person, right, first name, and then we pass in whatever variable we want. So let's make it this time Alan. So Alan, and we can do the same thing for last name. Copy, and let's do last name, and for last name let's pick Marshall. Okay, and so now when we have that, you can see that it did that. So that is a way to set the values, and of course you have scanf, so you can also get the value from scanf. So you can say printf, and you can say enter a value, enter first name, and you just do that, and then say scanf, and you can say %s, and you can say person dot first name, and it gets the first name, and we want to do the same thing for last name. Enter last name, and we can do the same thing. And notice that I'm not using the address of operator because it's a string. Now we're going to do the same thing for age. And we say enter age, and for age we need a %d, something doesn't look right here. Okay, okay, it does look right. So, and then we say age, but this time for age, just like with anything else, since it's a value type, we have to pass the address of operator. And so it says enter first name, I enter my name, and then I enter my age. And you notice that it didn't do my age. What's wrong with my age? Okay, so person and age. Oh, because I changed it here. I changed the value here. That's why it didn't do it. So let's not do that. Enter first name. I misspelled my own name. So, and you notice it has the values. So that is what you do with structs, and the structs allow you to group data, and you can put as many variables here as you want. I will stop at this point, and I will create another video to show you how we can access them by functions. So I'll stop the video at this point. As always, if you like this video, give it a thumbs up. If you are willing, go ahead and subscribe, and there's more videos coming your way. For now, that is all I have. Thanks for watching.